Welcome to another deep dive. This one's all about the life and work of Michael Faraday, a real game changer in 19th century science.
Oh, yeah. Faraday's story is incredible.
And we're going deep into a biography that zooms in on his scientific achievements.
Cool. It's amazing how he wasn't your typical scientist of that time.
Not born into privilege, right?
Right. And his formal education was limited.
So how did he end up at the Royal Institution, like the heart of science back then?
His curiosity, pure and simple, and a real passion for science. He didn't see science as just cold and analytical.
He was deeply religious, I read. How did those two worlds mix for him?
Well, he believed his work was like uncovering God's design.
Wow. So for him, understanding nature was like understanding the divine.
Yeah, you could say that. That really influenced his scientific approach.
That's fascinating. So from bookbinder to famous scientist, what a journey.
It really is. Started as an apprentice to a bookbinder.
Far from labs and experiments, huh?
You got it. But as an apprentice, he had access to tons of books, and he read them all.
Always learning, eh?
Constantly. But attending lectures by Humphrey Davy, a top chemist at the Royal Institution, that's what changed everything.
I read he took super detailed notes during these lectures. Like, he knew this stuff was important.
He did. Those notes showed how dedicated he was, really impressed Davy. And that's how he got the job as Davy's assistant.
What a break.
It was. That opened the door to the whole scientific world for him.
Didn't stop there, right? They traveled all over Europe together, meeting other big-name scientists. A scientific road trip.
Exactly. That exposed Faraday to so many different scientific ideas, really broadened his horizons.
And there's this great story about them climbing Mount Vesuvius.
Oh, yeah, I love that one.
They had a meal on cooling lava toasting to England.
Talk about adventurous. He wasn't just stuck in a lab, that's for sure.
Okay, before we get to his big work with electromagnetism, we have to talk about his early chemistry discoveries.
Oh, absolutely.
They often get overshadowed, but they're super interesting. Like, he discovered benzene.
That's a huge one. It's a key compound in organic chemistry.
What's it used in, exactly?
You name it, from plastics and resins to dyes and pharmaceuticals.
No kidding. So modern chemistry relies on it.
Totally. Can't imagine it without benzene, really.
Wow, that's impressive. And didn't he also contribute to developing, well, a tool that's everywhere in labs today?
You mean the Bunsen burner? With that blue flame.
The one and only.
Not exactly in its final form, but he helped develop a device that mixed air with gas to create a hotter, more efficient flame.
So he paved the way for the Bunsen burner?
Exactly. Lab work would be so different without it. But wait, there's more. Faraday was the first to liquefy a bunch of gases.
Liquefy gases. How'd he do that? Sounds almost magical.
It's all about critical temperature and pressure.
Yeah, we're getting technical.
Think of it like squeezing a sponge. You get water out, but eventually, no matter how hard you squeeze, there's no more water left.
Okay, so what does that have to do with gases?
Every gas has a critical temperature. Above that, it can't be liquefied, no matter how much pressure you apply.
Uh-huh. So it's like a limit.
And the pressure you need at that critical temperature to make it liquid is the critical pressure.
So Faraday figured out how to manipulate these things. Like he was controlling nature.
He was a master at it.
Yeah.
And using this knowledge, he liquefied chlorine, carbon dioxide, hydrogen sulfide.
That's incredible.
These discoveries weren't just theoretical either. Think refrigeration and loads of industrial processes.
So his early chemistry work alone is super impressive.
Absolutely. But for Faraday, this was just the warm-up. His real passion was the mystery of electricity and magnetism, and that's where things get really wild. So back then, electricity and magnetism, they were seen as totally separate forces.
Like two different worlds, huh? No connection.
Yeah, but Faraday, he had this hunch. He thought they were linked somehow.
Interesting. What made him think that?
Well, there was this experiment by Hans Christian Ørsted in 1820.
Okay.
Ørsted saw that an electric current could move a compass needle.
Really? So electricity, something you can't even see, was messing with a magnet.
Exactly. It blew people's minds back then.
I bet. It must have challenged everything they thought they knew.
Oh, totally. It showed a connection between electricity and magnetism, but no one knew why or how.
And Faraday, he wasn't the type to just let it go, was he?
Nope, not at all. He had to figure it out. But here's the thing. He wasn't a math whiz.
Ah, so that held him back.
Actually, it might have helped him. He had to think differently. He visualized things.
Visualize.
Instead of all those equations, he saw magnetic forces as lines and fields.
Hold on, back up. What was the thinking back then?
They believed in action at a distance, that forces could act instantly across space.
So, like, magnets just magically attract or repel each other?
Basically.
Yeah.
But Faraday wasn't convinced. He imagined these lines of force like an invisible web connecting everything.
Ah, so the lines of force are the connection, not magic.
That's it. It was a radical idea, and it led him to build the first electric motor in 1821.
No way, the very first one.
Simple version, but yeah. He made a magnetized rod spin around a wire with electricity flowing through it.
So he was using those invisible forces to make something move.
Exactly. That experiment opened up so many possibilities, electric motors, generators, all that stuff.
Wow. And after that, he just kept going, right?
Oh yeah, he was on a roll.
Yeah.
In August 1831, he built the first transformer.
Transformers. They change the voltage of electricity, don't they?
Yeah, think of it like a bridge for electrical energy. It transfers energy between circuits, but without a direct connection.
I see. Like a translator between two languages.
Perfect analogy. That's how we send electricity over long distances today.
Me too.
Imagine our world without transformers.
Everything was shut down, right?
Pretty much.
Okay.
So he built this transformer, and then boom, he discovers electromagnetic induction.
Electromagnetic induction. What's that in plain English?
Picture a copper wire just sitting there. Then you move a magnet near it.
Okay.
Faraday found that the changing magnetic field from the moving magnet could create electricity in the wire.
Wait, he made electricity appear just by moving a magnet?
He did. Back then, batteries were the main source of electricity, and they were pretty limited. But Faraday's discovery meant you could make electricity from motion.
So that's how we got dynamos and eventually power plants?
You got it. Large-scale electricity generation.
Yeah.
Faraday started it all.
Amazing. So everything we rely on today, it all goes back to these experiments from the 1800s.
Pretty incredible, right? But there's more. Faraday also figured out the laws of electrolysis, how electricity and chemical reactions are linked.
So he was connecting all these different areas of science.
He was a master at it, and his laws helped us understand more about atoms, even though he didn't have the full picture at the time.
And his work on dielectrics, materials that don't conduct electricity well, like the Faraday cage, that's a classic.
It is. That's an enclosure that blocks electromagnetic field, like a shield.
Like a force field, protecting things from interference.
Exactly. It's used everywhere, from protecting sensitive electronics to keeping people safe around high voltage.
Faraday was thinking way ahead of his time.
He was. So we've talked about his amazing discoveries in chemistry and electromagnetism, but there's another side to Faraday. He was passionate about sharing what he knew.
He wasn't content just keeping it all to himself, right?
Not at all. He wanted everyone to understand science, not just scientists.
He was a great communicator, I've heard.
He could make complicated stuff easy to understand. He gave public lectures at the Royal Institution, and his Christmas lectures for kids, they were legendary.
Imagine that, making science fun for kids.
One famous lecture was about the chemical history of a candle, something everyone knows.
Showing how even ordinary things have amazing science behind them.
Exactly. Clarity, no jargon, connecting with people, that was Faraday's gift.
He sounds like a born teacher, and the Royal Institution still carries on that tradition, right?
They do. Faraday's legacy of making science accessible, it's still going strong.
It's inspiring to see how his influence continues. And it goes even further. His work on electromagnetism laid the foundation for the electric world we live in. Even Einstein was inspired by him. It really makes you think, how one person, just driven by curiosity, could change the world. We're talking about changing how we understand the universe.
It is amazing, right? The power of science to make a real difference. Faraday's discoveries, they weren't just ideas, they led to actual things that we use every day.
Right. And it all started because he wanted to understand things, to challenge how people thought, to see connections others missed.
Exactly. And there's this great story about him. Someone asked what good electricity was, practically.
What did Faraday say?
He said, "One day, sir, you may tax it." Think about it. Back then, electricity was like a novelty.
Like a magic trick almost. He could see the future.
Totally. He knew electricity would be everywhere, important enough to be taxed. And he was right. It's the foundation of modern life.
Can't imagine life without it. Everything runs on electricity, from our homes to hospitals, everything.
And it all goes back to Faraday's work, his experiments. He wanted to understand nature's forces, the fundamental stuff. But what's really cool is that even with all his success, he stayed humble.
He didn't care about fame, did he?
Not at all. He turned down awards, titles, all that. He focused on his research and his faith. That says a lot about him.
He was a very religious man, right?
Yeah, part of the San Emanian Church. Believed in a simple life, dedicated to understanding God's creation. Science was like his way of appreciating it all.
It's really inspiring to think about his dedication. But he had his struggles too, right? Our sources mention some health problems later in life.
Yeah, his mind and body, they kind of wore down, probably from pushing himself so hard in his research.
It shows how demanding scientific work can be, even for the best minds. Makes his achievements even more impressive.
Definitely. He kept going, even when it was tough, and kept making these groundbreaking discoveries.
He might not have found the ultimate answer, but his search for how everything's connected, that still inspires scientists today. His story is a great example of curiosity, never giving up and thinking outside the box.
It really is.
So what does this all mean for our listeners, right? What can we take away from Faraday's life?
I think it shows that amazing discoveries can come from anywhere, from anyone. He wasn't born into a scientific family, but his curiosity and dedication, that's what made him a revolutionary figure.
It's a good reminder that anyone can pursue knowledge. It's not just for academics.
Right. You don't need fancy degrees or labs to make a difference. Faraday proves that.
Faraday's story tells us to question everything, to think differently, and never stop exploring.
Exactly. Who knows what you might discover if you approach things with the same open mind that Faraday had.
And on that note, we want you to think about this. What simple scientific things fascinate you? What could you discover if you followed those interests? Keep exploring, keep asking questions, and keep Faraday's spirit alive in your own pursuits.
That's it for this deep dive into the life and work of Michael Faraday. Keep diving deep into the knowledge that excites you.